Hello everyone, I am Gu Hechen, and what I want to talk about today is electromagnetism, Lenz law direction of induced current and magnetic field. By the end of this section, you'll be able to calculate things like electromotive force, current, and magnetic fields using Faraday's law. And you'll also understand the physical effects of Lenz's law. The key takeaways: Lenz's law and Faraday's law tell us two important things about the way a changing magnetic field interacts with a loop of conductor. These two fundamental physical laws come together to govern how magnetic fields are generated by conductors carrying DC or AC currents. Lenz's law states the direction of an induced current, and Faraday's law relates the magnitude of the induced back EMF to the rate of change in the inducing magnetic field. Inductors and transformers wouldn't work if the fundamental laws of electromagnetism didn't exist. We'd only have an electric field and no magnetic effects produced by moving currents. The two basic electromagnetic laws that describe the relationship between induced voltages and the magnetic field are Lenz's law and Faraday's law. At the PCB level, these two laws combine to produce inductive coupling between the different circuits. Flux and magnetic flux specifically affect electromagnetics directly, and to understand the relationship to matters like Faraday's law and Lenz's law, you'll be looking at core subjects like electromagnetic induction or induced EMF, flux linkage, electric current and induced electric field, Lorentz force and magnetic field lines. Whether a uniform magnetic field is at play or a changing magnetic flux is at work in your wire loop or electric field at large, you'll want to be sure you have a good gauge of flux density and magnetic field strength. If the term inductive coupling sounds vague, just remember we're talking about crosstalk, EMI, noise transfer, and any other way the magnetic field might induce noise in an electrical circuit. To better see and predict when a signal in one area of a PCB can induce noise in another area of a PCB, it pays to know something about the difference between Lenz's law and Faraday's law. Here's how they differ and where they lead to crosstalk in a PCB layout. Faraday's law: when a magnetic field is incident on a coil of conductor, the magnitude of the electromotive force, EMFT, induced in the coil is directly proportional to the rate of change in the inducing magnetic field, and dot product between the field direction and the axis of the coil. Lenz's law: understanding electrical energy means understanding current direction and conducting loop, as well as any changing flux, mechanical energy, or varying magnetic field in your product. Lenz's law is actually the counterpart to Faraday's law in that it tells you the direction of an induced current, but not explicitly. Lenz's law: when a magnetic field induces a current in a conducting coil, the induced current also generates its own magnetic field that points opposite to the inducing magnetic field. Applications of electromagnetic induction, another contemporary area of research in which electromagnetic induction is being successfully implemented and with substantial potential, is transcranial magnetic simulation. A host of disorders, including depression and hallucinations, can be traced to irregular localized electrical activity in the brain. In transcranial magnetic stimulation, a rapidly varying and very localized magnetic field is placed close to certain sites identified in the brain. Qigong, weak electric currents are induced in the identified sites and can result in recovery of electrical functioning in the brain tissue. 大汤啊你 sleep apnea 章 The cessation of breath affects both adults and infants, especially premature babies, and it may be a cause of sudden infant deaths, (SID3). In such individuals, breath can stop repeatedly during their sleep. An cessation of more than 20 seconds can be very dangerous. Stroke, heart failure, and tiredness are just some of the possible consequences for a person having sleep apnea. The concern in infants is the stopping of breath for these longer times. One type of monitor to alert parents when a child is not breathing uses electromagnetic induction. A wire wrapped around the infant's chest has an alternating current running through it. The expansion and contraction of the infant's chest as the infant breathes changes the area through the coil. A pickup coil located nearby has an alternating current induced in it due to the changing magnetic field of the initial wire. If the child stops breathing, there will be a change in the induced current, and so a parent can be alerted. That's it for my report. Thank you everyone.